Today, this is Analyzing Big Data with Microsoft R Server. I'm Derek Norton, and just a little bit of background. I'm currently a lead data scientist in the Microsoft Consulting Services, but I worked at Revolution Analytics for 4.5 years prior to Microsoft purchasing us. So this is what I did on a very every minute of the day, 70 hours a week for 4.5 years. So hopefully, if you have any questions, ask them. If I don't have something, I have a lot of code which is going to be shared. I have code that covers most everything that I talk about that's in the exam. But if there's something you want to see that you don't see there, I possibly could write that code quickly if there's not many of us here. So we'll see. All right, so the objective here is at the end of this session, you of course want to be able to, I guess the main objective is probably you want to be able to take and pass the exam, 70773. However, I would say that the most important piece is that you can actually better use Microsoft R Server, because if you can answer the questions on the exam easier. You want to be able to work with the big data, because that's actually the focus of Microsoft R Server, which means you can do that, you can pass the exam. And I'll say build machine learning models, because there's a lot of questions about machine learning models, so that's probably something you want to be able to do also. A little bit about certification in general. I don't know how many of you have taken exams. Have any of you taken exams, any of the other exams? You already had some? Okay. The Microsoft Certified Solutions Associate, just to quickly say, that's what you're going to be taking here if you pass 2 exams. This exam counts toward one of those, and if you only need 2 more after that, so that's not too difficult. If you take those 2 exams, you can get the Microsoft Certified Solution Associate, but it really only takes one more electoral type of exam to get the Microsoft Certified Solution Expert. So this exam, it's 40 to 60 questions. You get an hour, 1 to 3 hours. I guess you can do it as quickly as you possibly can. I will say I took it prior to the first time I taught this certification thing, and I think I finished it in 30 minutes. Now that being said, I use this a lot, and I spent another 30 minutes writing comments about it. So you can review most of the questions. Take your time, look over them. If you're not sure about them, look over them. And it can be up to 20 different types of questions. So 700 is passing. That's the equivalent of 70%. All right, so what I'm going to do is talk about some broad topics and then talk about the individual components that you will see in the exam. I will give a forewarning, and this is probably every certification, if you've been to one of these talks, is that I'm going to talk about this. You're not going to learn enough about it in this talk to be able to pass this exam because there's just too much stuff. I have a lot of code. It'll point you to a lot of other stuff. I have 2 pages worth of links that shows how to do some things that you probably didn't expect to be on the exam. So reading and exploring big data is the first piece. A very important component of working with Microsoft R Server is, of course, reading data in, right? Most of the time, you're not going to have data in a format that you're ready to use. Depends on the platforms that you're working on. Sometimes you can work directly off of CSV files, things like that. However, many times you'll want to read from a different sort of file. And so it's important that you know how to read all types of data files, text files, SAS, SPSS files, how to convert to the XDF format. XDF is really important because XDF sort of is it's the bread and butter of how most of the work on Microsoft R Server is done, unless you're working in SQL Server. In that case, you're probably working on a table. Let me ask a question. How many people here have used Microsoft R Server for more than 15 to 20 minutes? 1, okay. You're going to really benefit from the links at the end of the thing because there's a whole lot of things, lots more code than what I show. All right, so that being said, for those who haven't used it, an XDF is an external data frame. External data frame is a binary file format. It was developed because it stores whatever data you have in a chunk-wise format. It allows you to read data in by chunks, process on a chunk, so you can actually operate on really large data. You can certainly do that directly from a CSV file, but you'd have to sort of chunk as you go, read down the file. This does one import to an XDF and then allows you to have random reads across chunks, so it's actually much more efficient. It's very fast. So it's important to be able to identify the benefits of using the XDF and trade-offs. For the most part, unless you're on SQL Server or on Hadoop, an XDF is probably the best thing to use. SQL Server, you won't, right? It's going to use a table. You're going to operate on tables for the most part. In Hadoop, many times you're working in a process flow where other people may do other work in Hadoop, and so putting it into the XDF may just be an extra step that's not required. Now, that doesn't mean it's always not required. Depends on how much processing you do. If I do one thing to the data with Microsoft R Server, you might not worry about doing that conversion to XDF. If I do more than one thing, that conversion to an XDF, that overhead is probably worth it because that second thing will be so much faster. Also, you need to know how to read through ODBC connections. And again, I have code, so don't worry. When I get to the end of this section, I'll show code that some of this is done and how you can find some more information about doing the ones I don't show code about. You can also use an internal data frame. So let me ask this. Have everyone here used R? No? Okay. All right. So R tends to operate generally on data frames. If you're doing data analysis, data frames is the sort of standard format for data analysis used in R. There are, of course, other ways to store data, but this is the sort of analytics type storage. Any data frame can be used in any of the functions in Microsoft R Server. So anywhere that I might operate on a text file or an XDF file, I actually can use that exact same function on an internal data frame also. Summarizing data is important in general and on the exam. So understanding how to compute cross tabulations and univariate statistics, and those are done generally with one of three functions. Four if you throw in quantiles. One is RX summary. The other two that sort of go together, RX crosstabs and RX cube. And that third one, if you throw it in there, is RX quantile. It is important to know, because there are questions specifically about when would you pick one of these things. When would you use RX crosstabs versus RX cube? I will hold off for the moment because I think when I show the code, it'll make a lot more sense about how to make those decisions. But I will just simply say that a crosstab is think of it as sort of a matrix, right? If I have two factors, it sort of spreads it out, and a cube is sort of long direction, long versus wide, I guess. It'll make more sense when I show it. Now, this is an important thing to note, is it says integrating open source packages such as dplyr XDF. This is really important because I would say I didn't expect it to be on the exam. dplyr is a very common way people tend to write R code, and dplyr XDF allows you to use those dplyr verbs on XDF files. This is not technically a Microsoft supported package. It is written by someone at Microsoft who was also at Revolution Analytics, and if my push to Nagesh was strong enough, hopefully it'll be part of the product coming up soon. But it is on the exam. So understanding at least a little bit about how dplyr works is important. I have some code that shows it, but I will say that there's a vignette for dplyr XDF that actually covers everything you need. It's 5 or 6 pages. Just look through it, and the link's at the end. Another thing to know is when to use group by. And again, if you don't know what dplyr is, understanding what group by means makes no sense either. I have a little code snippet. Think of it as just grouping your data. I do summary statistics, and it gives me summaries by something else. Creating formulae is really important, pretty much across the board in Microsoft R Server, because it allows you to do various sorts of summaries by groups. When you do predictive modeling later, you'll also use these formulae. In R, a formula is pretty much the way you define how something relates to something else across lots of different functions. You also need to understand how to do quantiles with RX quantile. And again, so far I think everything I've said I have an example of code for, so we'll go back to it and you'll see it. But that being said, you really need to look at the help files. And I will say in my code, I have a lot of places that actually has the call to the help file, so you can look at that also. Not just my code, but also the help files that you want to see. Visualization is important. There are a few questions that will come up about visualization. Most of them relate to RX histogram and RX line plot, which are actually quite straightforward. However, there are questions that are specifically about using ggplot2. ggplot2 is an open source package, so again, a bit of a surprise. You may not have expected it. I didn't put it in there. I was surprised it was in there. But a little bit of understanding about ggplot2 is important also. I have an example, and actually, if you go read a little bit about the vignette about ggplot2, it's relatively straightforward. It uses a very similar interface to dplyr. You can create custom visualizations using things like RX Summary and RX Cube. So if you do a summary on your data, you can get that summary and then use like open source R functionality to do plotting. Facets, there is potentially, I don't know 100%, does this end up, but there are questions about facets in plots. So how do you get a facet in a plot? Faceting in R, for those that have not used R, is a fairly straightforward thing. You just use the pipe and not the R pipe, but the sort of standard up and down pipe. I don't want to confuse. There's a thing in R called pipe also, but it's not that pipe, it's a different pipe. Yes, sir. It is pretty much, well, so it is case studied, right? But what you get in a particular case study is somewhat random. Are you going to get a summary, you know? Now, like where it says custom visualizations, if that pops up, you'll have something that'll say, you've done RX summary, you're going to do a plot following it with ggplot, something like that. It is case study based, except, or for the most part. I do remember when I took it, there were 1 or 2 questions that were just sort of a random question. But most of it is like you'll have maybe 5 to 6 or so questions about a particular topic. Well, I don't even want to say one data set. It's not around one concept. I mean, I think that would make sense, but that's not the way it's laid out. It's sort of like the case study is, here's data from a particular, you know, pick something example, and there's questions that relate to that. You might do a summary, you might do a plot. Now, topically, it's only similar because it's the same data. Okay, so let's jump to exploring data with code. You let me know, can you see that okay? Okay, good. All right. Oh, now you can't see it at all. Okay, still there. All right, so in R, for those who haven't used it, putting a question mark in front of a function call will give you the help file for it. This help file, RX data source, is a great place to look when we talk about reading from various data sources, SAS, ODBC, those sort of things. I'll just go ahead and bring it up. If you open this one up, you'll get the help file for, or you'll get a pointer to all of the choices down there. And I know the help files are a little bit small. But when you scroll down, the see also, oh, that's super tiny. Hold on. It's slightly better. Under C also are links to the various types of data sources you may use, and I apologize, these are small. RX text data, RX SQL Server data, which is, of course, data inside of SQL Server, RX SPSS data, and so that's one of the binary SPSS files, RX SAS data, which is SAS7 BDAT files, and then RX ODBC data, RX Teradata, and then RX XDF data. Generally, you will tend to have sort of a single import from one of those and then use XDF for the remainder. Here's an example of reading in a CSV file. What you need is a pointer, of course. You know, this first part. You'll see this sort of thing when you look at code, so it's important to understand what's happening here. File path actually just creates a file path. It doesn't do anything in particular other than set up a text string. So if you look at it, it just tells me that data is located, you know, in /r/r server so and so and so and so. That's all that particular file path statement does. Now, to create a data source, we use rxtext data here. rxtext data knows, and I don't want to call it intelligent. It has a CSV, .csv, and so it assumes it's a CSV. That's the only extent of that it knows. It's not intelligent. It didn't check or anything. It said .csv, so it assumed it was a CSV. If you have a tab delimited file that you have written as something .csv, it will still assume it's a .csv. That being said, I'm going to import use this real quick. If we look at the help file for rxtext data, you can see that there are lots and lots of options here. And these are options if you're reading a text file that's not a CSV base. You know, things if I have different delimiters, if I want to actually pass what type of columns. And there potentially might be questions about this. Understanding column classes is really a good thing. You're much faster at importing if you know what things are ahead of time. The function's just faster. But anyway, as you can see, if we scroll down a bit, things about delimiters, combining multiple delimiters, things like that. All right, so we saw what the CSV inputs underscore CSV underscore file was. When we've defined a data source, we can see now that this actually is a more complicated object. It's a text data source. It tells where that data is located. It has a few of these options that are set automatically for you. What is a century cutoff? How many rows does it look at to make sure that it picked the right column type for things? How many rows is it skipping before it starts reading? You know, say you have a bunch of header information, you want to skip over those, you can set that. I didn't set any of these, but as you can see, there are defaults for a lot of these. Now, that being said, this data source still didn't do anything. It's just a pointer to this file that tells you how you would read from this thing. And that is true about all data sources. They don't actually do anything until you operate on them. One way to operate on them is to import them. So I can import them here to a CSV file. So first off, what I'm going to do here is just set up a path to a new file, which is an XTF that doesn't exist. The import takes at its most base an in data and an, well, technically, you don't have to have an out file. Just as an FYI, if you don't specify out file, it is defaulted to null, which means it tries to read it into RAM. Now, if your data is huge and you didn't want to do that, there is a argument in there that says max rows by columns that will say you have too big of a data file, and it doesn't try to do that for you. So let me just run that. Actually, I'll let you see while it does it. So we've imported that, and now we have an XTF data source, which is just like a text data source, except for that import created that binary file that I can then use this in subsequent function calls. All right, this is just an example to show that you can do the same thing with a data frame. So if I created an in-memory data frame, this is just something that's sitting in RAM as an object. Just X1 and X2. I can also use import on that. and that will import that into an XDF file. This particular one is just located at test.xdf. I just made up something there. All right. Another piece that we want to look at is ODBC connections. The thing is an ODBC connection is the same as any other data source for the most part. And that is, once I have it, I can use that data source in any function. Now, what I need for an ODBC data source is one of two things. I either need a table, a pointer to a particular table. That being said, I need more than two things. I do need something that points to the database. So there is some options that you can either use individual things like database name, or you can create a database connection string directly and pass that also. But once we have that pointer to the database itself, you need one of two things, and that is a table or a query. A table, let's just say you have a table named Iris, like the Iris data, you can just say Iris. It'll import that entire table or bring it in when you do processing on it. The other option is a SQL query. You can select, if you said SQL, select star from Iris, that's the same as just saying Iris as a table. But you can do any sort of queries that you might do there. All right. So I'm going to just call this working data just to show here. We're going to use this for the remainder of the examples. This is car data, age of a driver, car age, type, cost, a number of cylinders there, which is somewhat irrelevant to what we're doing, but it is something that we need. All right, so we talked about running summaries on data. If we want to summarize, remember the three functions that you will generally use, and the fourth is when you don't use quite as much, the fourth RX quantile. Three functions you will generally use are RX summary, which gives things like your mean, your min, your max, number of missing, things like that. And then the other two, RX crosstab and RX cube, which are, think of them as roughly the same function, they just return data in a different format. RX crosstabs will give you sort of a table, and RX cube will give you a long format. So here you can see that we need to use a formula. If you look at that formula, I don't have anything on the left-hand side, but this says I want a summary. Since I have nothing on the left-hand side, what it pretty much says is give me the information about row number, cost, and number. Since this is a summary, it's just going to give me your general summary statistics. Let's run that. And you can see what I get when I run that is your mean, standard deviation, min, max, valid observations, and missing observations for row, cost, and number. Now, just to show the function summary, which is an open source R function, has an object-oriented version that runs on an XDF file. So if you say summary, what that does is actually does RX summary on every variable in that XDF file. Now, on a really big XDF file, that's a terrible idea, but just realize that if you do it, it's going to try to do that for you. You can see here that when I do summaries on factors, instead of giving me min, max, that sort of thing, what it does is gives me counts. It gives me the same sort of summary as open source R would give. All right, so the next thing is crosstabs. Crosstabs is a cross-tabulation of things. Here, with my formula, I've added a new piece, and that's the colon operator, and that's saying I want age by car age. So if we run this, now this is not particularly interesting because this data set is very balanced. So there are 4 of each one of these possible outcomes. But as you can see, what we get is data that is spread out. So we have age by car age. Now, you can compare that with the RX cube. Say the formula is the same. What I then get is data in a long format. Same data, no different, it's just in a different format. Now, generally, if you want to save the results of something, this is probably, you'll want to save this way, especially if you have very, very large data. And just as a FYI, XDFs are not great when you have thousands and thousands of columns. It's not real good at that sort of thing. So this long data format is a much better format for it. It's just easier for it to store and access. All right. You can also see that I can get, instead of just counts, if I pass a variable on the left-hand side of the tilde there, I can get summaries about that particular variable. So before, here I had age and car age. All I did was get counts. When I pass this, what I'm going to get is either the means or the sums. Here we have an argument that says means equals true. I could get sums if I just said means equals false. So if I run this, you will see, instead of having counts now, I have the average cost by the person's age and the car age. The same is, again, also true of RX cube. I just get it in a different format. There is one slight difference here, and I said they are exactly the same. Not quite. When we do a summary like something on the left-hand side, RX crosstabs wants to give you the sum as a default. RX cube wants to give you the mean as a default. So as you see, I said mean equals true. I don't say anything here because RX cube is going to automatically try to give me the mean. So if I run that, you'll see what I get is the same sort of thing, but look here, I also got counts. Now, that being said, here you see the counts. In the other example of RX crosstab, technically I have the counts, it's just not the table that prints when you do the display of what's in there. So you have both tables, you have counts and the means. All right, so I mentioned dplyr XDF. dplyr XDF actually is just think of it as a wrapper around the functions that we have in RevoScalar, which is the package where all these things you're seeing sit, that allows you to use the verbs you would use in dplyr. So dplyr XDF, if we load it here, allows us to do things like this. Say, I want to take working data, which is the XDF file I had. This is the Magrittr pipe from the Magrittr package in R, and I want to count a count of age and car age. So this actually returns the exact same thing that our RX cube did before. It actually saves that for you into an XDF without you having to do anything. So if you have really big data, this is nice. It did something for you. You didn't have to worry about it. But if we were to look at all of it, it only has 32 rows. This is the same as the output would have been from RX cube. All right. Now, group by allows me to do grouping and then summarize on those groupings. So here, I take my original working data. What I want to do is group by age and car age, and then I want a summary on that. I want the mean, and then I just want the count, which this again will give me the exact same output that I had from RX cube. A little bit more verbose maybe than RX cube, because RX cube said just pass the formula. But the thing is here is that the intention of dplyr is to have sort of a logical step of things, and that is take my original data, group it by something, do something to it. So it may be a little more verbose, but it is much clearer maybe what's happening there. And if I look at that, you can see that I had the same output that I had from RX cube previously. All right, the last function was RX quantile, and this is a way to get approximate quantiles. And I said it because these, an actual quantile, if you want to calculate that, you need to sort your data. This does not sort data. This uses the empirical distribution function of your data. Think of it like binning your data, and then it calculates an approximate quantile. If your data is relatively well behaved, these are accurate. It's meaning if I have, let's say my data is fairly central around a given area, but I have a huge outlier, RX quantile will be terrible. However, so long as I don't have some huge outlier, RX quantile, the approximate quantiles are quite good. The reason that this is this way is that everything in Microsoft R Server in this RevoScaler package, the intention is that I'm operating on potentially billions and billions of rows. Sorting that is very costly, and so these sort of functions are ways to get around that. If you look at the help file for RX quantile, you can see a link to the paper that talks about the approximate quantiles there. But for now, we'll just say it happens. If you want to see why, that why is not on the certification exam. Running a quantile, if I don't pass it any numbers, it gives me the minimum, the maximum, the median, and then the 25th and the 75th percentile. The only thing different that I can actually specify what probabilities, what percentiles I end up getting. So this sequence says I want 0 through 1 at 10% increments. So if I run this, it will look slightly different, and that I get the minimum, maximum, and then the 10th, 20th, 30th, 40th, so on up percentile. Honestly, if you know that about RX quantile, you're good. There's not a lot of questions about it, so just understanding how you would use it, that's good enough. Okay. Oh, sorry. We have one more, I think, about visualizing, which was part of that. All right, so we said you can create custom visualizations. Before you saw me create a crosstab, so I'm gonna save that crosstab somewhere. I did not save it before, but just to show you what's inside of that, it is more than just that tabulation. There is a fair amount of stuff in there. A lot of it has to do with how the calculations were done, but if we scroll up here, you can see there's things about the data, and then there's some other stuff. For the most part, we only care about either the sums or the counts. Those are the things that we would create a custom visualization off of. And then you can see here that if I just extract the means, because that's what I wanted out of that, I save that as crosstabs. And then I can do things like use open source R functionality to create a, say, heat map. Sorry about that. Maybe. Okay. Didn't get the error before, but it did create the plot. Again, is this particularly interesting? Maybe not. But it does give me a graphical sort of thing to say if I have age and car age, I can see where those are slightly higher. You can do something a little bit better if I were to use ggplot, and I'm going to use that doing RxCube. ggplot tends to operate on things in long format, so this actually is generally how you're going to want to use ggplot as something from RxCube. But I also say go read about ggplot too. There's a link to it at the end of the presentation. But here, what it says is I'm going to take that cube that I have, average cost by car age and age, and then I'm going to use that data here. This AES is the aesthetics for ggplot, so just how ggplot works. It tells me this is my X, that's my Y. I want to add a tile that I want the value to be filled is cost, that's how it's going to fill. And then some things about themes. Those are worth looking at. For the most part, understanding how to create a plot in ggplot is what you need. The themes, not as necessary, but understand how to create a ggplot plot. So if I run it, I end up with something very similar to what I saw before. Maybe it's slightly prettier. On this projector, it doesn't look very nice at all, but a way to visualize what I got from the summaries. All right, two other things that were mentioned were Rx histogram and Rx line plot. RX and histogram and RX line plot look exactly the same the way I call them, except one would be RX histogram and the other one would be RX line plot. So for a base histogram, I can just say I want a particular variable that will give me one big histogram. We talked about faceting. Here is that pipe. So this is cost, but it will create a plot, a separate plot by different ages. So if we look at the first one, which is just a histogram of cost, you can see that here is what cost looks like. If I run the second one, it creates a faceted plot. So here's the ages, and then a histogram of the data that sits in each one of those age buckets. Okay? All right, so now we'll talk about processing big data. For the most part, the function you would probably use the most in Microsoft R Server is RxDataStep, because it is the function that actually just steps through large amounts of data and allows you to do things with that data. You need to know how to subset rows from that. There are questions that will show up about subsetting. How to create new columns using the transform argument, and I have examples of that. How to choose when you might want to use an on-the-fly transformation versus doing it on the data itself. All of the Microsoft R Server functions have, this transforms argument, which means that, let's just say I'm running a regression. I can actually create that transform as I'm running the regression and then run the regression. It doesn't save the transform anywhere, but it would be used in that. Sometimes that makes sense, especially when you're playing around with things. You know, if you are doing something that will be used for subsequent analysis, of course it makes sense to actually save those somewhere. Another thing to consider is how to handle missing values. You can do this with filtering, or you can replace, I have an example of that also. And then, do you want to create a data frame or an XDF? I mentioned that earlier. If you don't use an out file argument, you'll get a data frame. Sometimes you want that, sometimes you don't. And then you want to understand a little bit about processing dates. There's really two main ways to deal with dates inside of R. That's that POSIX CT and then POSIX LT. Just understand what you're working with there. If you search for POSIX CT, say, in R, you'll get a help file to talk about the difference between those two. But it's just something you want to spend a little time looking at. Now, the first thing, transforms, is generally simple transformations, row-based, if I were to take a log of something like that. If I want to do something more complicated, there is something called transform func. This is a function that you can create that can do all kinds of things. You can, and I'll show how to do it, create a transform function, how to reshape data using a transform function. And I will say this, I want to warn, I'm front loading here. This stuff is actually the stuff that most people don't know how to do with Microsoft R Server. Building a model is really easy. It's just like open source R, it's just calling a different function, so don't get worried that we're getting close to the end. I've spent a lot of time up front. This is the stuff that is different than you would do in open source R, I think. You can reshape data using a transform function. Just realize that everything in Microsoft R Server works chunk-wise, which means I'm not operating on all my data. So if I do things within a chunk, that chunk doesn't have any visibility to the rest of the data. That's something to be wary about, because if I were to do, say, a median, think about this, a median of part of the data and the median of all of the data are not the same thing, of course, right? Now, if I were to take medians of all those chunks and the median of that, is that the median? No. Now, if I were to take sums from each one of the chunks, sum it all up and divide by the total count, that is the mean, but that doesn't necessarily hold for other statistics. Something just to be wary of there. Now, again, here's a open source package. There are questions that may or may not come up about using the package Lubridate. Lubridate is for dealing with dates, and I will say this, as much as it's not great that there's a question about an open source package this makes dealing with dates a lot easier than sort of the general open source R. It makes it easier than the base R functionality for dealing with dates. Another option you can pass to every function really is transform vars or transform environment. And what this does is says when I have a transform that I want to do, maybe I don't want to send, let's say I have 10,000 columns. I don't want to send all 10,000 columns. I just want to operate on 4 or 5. It is much more efficient to specify those 4 or 5 with transform vars, and that way only those variables are brought into the environment where that transformation is done. The rest of the 10,000, however many you have, aren't brought in. Transform envir, or transform environment, is a way to box up a bunch of stuff that you want to pass into the transformation environment to use. This is important because open source R is always doing processing right here, same environment that you do all your work in. Microsoft R Server, generally may be run remotely. You may be connecting to another compute context, which means your processing is done somewhere else. So you need to ensure that the things you need are explicitly passed to those environments because they aren't implicitly passed. Understanding how to use the internal .rx variables, these are important. If you want to talk across chunks, you can do that, and you can do that via these variables. I have an example for that. Excuse me. The next piece, talking about managing data sets. Generally, this is about sorting and merging. This is relatively straightforward. There's a function rxsort that allows you to do sorting. It has an argument to allow you to deduplicate things. So if I have rows that are the same, you can dedupe. Merging is rxmerge, and there are various options and what types of merges you can do. Your left join, inner joins, outer joins, all those are options. I'll show where you can find that information. And then understanding when you don't necessarily want to use these things. This is an easy one to say. Hadoop, and this has changed, but the test hasn't changed. In a Hadoop environment, you were not able to use rxsort and rxmerge before. That is not true anymore, but the test right now would still assume that is true. The newest version of Microsoft R Server actually leverages Spark to do sorting and merging, but previous version did not, and so that is generally where you don't want to use that. Additionally, if you're in SQL Server, you probably want to use the database to do those sort of things. This is not where you would want to do. You would want to do pre-sorting on a table before you brought it in, but those are really the only two places, Hadoop and SQL Server. All right, one last piece, and this is a new addition to Microsoft R Server beginning of the year. There's a package called Microsoft Machine Learning, or sorry, Microsoft ML. Microsoft ML exposes a lot of things out of Microsoft Research. Some of these are predictive models. Some of them are actually ways to deal with data. And so you need to understand there can be questions about featureizing text, which I'll point to that in the example. I do one example of this. If there's a lot, you just go read the help file, but I'll show an example of how to do it. Creating indicator variables and arrays. So Microsoft Machine Learning package actually has a way to create indicator variables and categorical hash variables also. And then there's also ways to do feature selection, which I'll again point to. All right, let me. All right, so I mentioned Rx data step. Again, the only necessity when you specify Rx data step is the in data. If I don't specify anything else, Rx data step really doesn't do anything other than read that data in. Doesn't put it anywhere, doesn't do anything else. Now, specifying out equals null means technically I don't have to specify it. If I don't say out file equals null, that is the default, which means it wants to read that into an XDF. Out file equals null means I'm going to try to read it into RAM. Here, row selection actually means I do something. In this particular example, it's just row selection is a logical statement in R. So this logical statement says the column age is equal to 17 to 20. So that'll just be a true-false Boolean, and where it is true, that is what will return from Rx data step. So if I were to run this, instead of 32 rows, 32 rows is the summary. What I did here is I only selected where age is equal to 17 to 20. So you see I have no variability there because it's all 17 to 20. Understand row selection, that's it. It's a Boolean, you just need to create a logical statement in order to get a row selection. So I show here, I could set something like file equal to working data. What that would do is actually try to overwrite my original file, which you can do, but I don't think I have it set here. Actually, I tell you what, I'm going to do this, and you'll get an error. It's an important thing to see because you'll do this. It'll tell you that you probably didn't mean to overwrite it, and if you did, you need to tell it that you meant to overwrite it. There's an argument called overwrite equals true. So I'll tell you what, I'm not going to run it. I'll just leave it as is. But here you can see the transforms argument allows me to create new variables. So transforms equals list. What I do there is a list actually holds multiple. I can have multiple transforms. So this list just allows me to hold multiple of these things. So what I'm going to create is something called older than 29. And what I say is age in 17 to 20, 21 to 24, or 25 to 29. And then I negate that. And so that's any of the ones that are not in those groups. So let me run that. Since I did not specify a file, sorry, it just wrote that to an internal data frame. And since I didn't actually save it anywhere, it just printed it out to the screen. And you can see what I have is my original plus a new column, which is someone older than 29. Okay. Another thing, of course, just to show with row selections, you can do things like say, just, is it missing? So we said you need to know how to deal with missing variables. In R, missing is an NA, not applicable. And so here, what I want to do is select all the rows where this cost is not missing. This is one way you can deal with missing variables. That returns all of it, and technically I'm pretty sure that is every bit of it because I don't think there's any missing in this particular file. But if there were, that would have selected the ones that are not missing. Another option is I could replace my missing with the average. Again, as I post there, this is not a great idea. This is not generally the way you want to do imputation, but as an example, it worked well. So this is relatively complex in that what I did first is take a summary of my data of cost. I'm extracting one piece here, and that is the summary data frame, and I only want the mean. So what I'm doing is extracting one piece. You can see here that I then have mean cost. You can see that is $238.45 and some extra cents. And then what I want to do is a data step, and then I can do the impute. So I can do an imputed cost to say, if cost is missing, stick this mean cost in there. If it's not missing, then just use the original cost. Now, remember, when we do transforms, it's in some other environment. So that environment doesn't know what mean cost is because it's not in my local environment. And so what we have to do is pass transform objects, and I just say mean cost equals mean cost. I know that's confusing because it's the same name. But technically what this is doing is saying, if I were doing this processing somewhere else, which I'm technically not right now, it passes that information over to that environment to do the processing. So when we run that, you can see I then have a column that is imputed with mean costs. I forgot, I did actually make some missing values. There aren't missing values in this originally, but I did pick some and make them missing. And so you can see here, where was it? Right here. Here was one that was missing. You can see now that that's filled in with the average that we computed. Yes? So, that's a good question. At the very end, I talk a little about it. It's called a compute context. Until I set a different compute context, it is always done right here, but transformations are done always with the mindset that they might be distributed. And so here, it is creating a new environment. It just happens to be local. So the transform is not happening in my current working environment. It is always going to be a separate environment. Now, whether that happens locally or happens on a different, an external server or something like that, depends on your compute context. It's called Rx compute context, and then Rx set compute context, and Rx get compute context. There's a little bit about that at the end of that. But those setting of compute context tells it where the Rx functions run. Now, open source R functions, which some things I've run here are just open source. They don't have an Rx in front of it. So let me say, Rx stands for remote execution. It can be remotely executed. All other open source R function only ever happens locally, right? Because open source R has no understanding of not being locally. Now, I can pass open source R functions like this. This is an open source R function call, but I'm passing it through Rx data step, which means that is then run externally, but only because it's going through that window of an Rx function. Does that make sense? Okay. All right, so sometimes, you can't just take a log, and I will say even that missing is a little slightly more complicated function, but maybe you want to do something that's really complicated. You can do that with something called a transform func, and you can see here that I'm creating a more complicated function. Let me talk about what's happening there. I calculated mean cost before. I also told you that it was not a good idea to do that. But here what I'm doing is I'm calculating mean costs by car age and type of car. So instead of one number, I have a lot of different variables, a lot of different values. Let me run it and let you see what that is. So now instead of just one number, 3.45, whatever, I now have an average value calculated across these different groups. Is this a good idea? Again, still not a great idea, but it's a good example. Now, in my impute function, what that does is it takes here, we generally write it this way. You'll see it in the examples, data list. Inside of a transformation, when it operates on a chunk of data, that data is surfaced as a list. Now, we can operate on that list. It's important to note this because it's not a data frame, and though a data frame is a list, a data frame has extra attributes that aren't in a list, and so understanding that it is a list alone is important. So what I'm going to do is pass these means, and I want to merge these together. This is an open source R function, merge. It's going to merge that small data set, those means, with the new data set. In this particular example, they have the same name, so it merges fine without me having to worry about it. And then what I want to do is from this work, take the cost that I end up merging in and sticking it into an imputed cost there. Now, if my original cost is missing, what I want to do is stick the imputed cost into that. That's what this does, and I know that's a little bit complicated. And then what I'm going to do is actually subset my data to get rid of that extra stuff. I just want to drop off those imputed. So what I'll return is one column. It'll be cost, and what I will have done is filled in that cost with the imputed cost, but matched up on age and type, I think it was. Yeah, age and type. So this function, as you can see, it is just a function. It hasn't done anything yet. It will be applied. So now I'm doing the same thing as before. I'm going to work on my working data, but instead of a transform, I'm passing it that impute x form as the transform function I'm going to use. I'm passing the mean costs as means. And I wanted to show this. I'm not using any packages, but there is another argument called transform packages that allows me to use any package that you might have inside of a transform. Important if you're doing things with, say, Lubridate or something. So if I run that, here's one you can see. There's a missing value. The imputed one now has an actual value there that's not the single value it was before. Okay, this help file is immensely important because it's not a function. Rx transform is not a function. So would you ever know to look for it? No, it's weird. So Rx transform actually just talks about doing transforms. So look for that, even though you wouldn't have, it's not an actual function. I don't know why they did it that way, but knowing that it's there is important. This tells you all about those .rx functions that I mentioned you need to know. .rx start row, .rx num rows. These all tell things about the chunk you're operating in. These are things you can use in transformations. And then there's two that you can do for cross-chunk communication. Rx, and I apologize, this is huge on my screen, it's tiny up here. Rx get and Rx set. The objects I pass into in transform objects, I can get the value and I can set the value. So I can change them as I'm doing processing there. That allows me to communicate across chunks. Modify does something similar, but it takes an object and then adds to it unless you change it. The default is a plus, and so it would take the original object and add something new to it, but you can change how it operates on it also. Again, relatively short here for sorting and merging because they're sorting and merging. They're not hard to do. It takes an in data, as you'll see. In data is common. We keep doing in data. The thing is, I need to tell it what I'm sorting by. I can sort by multiple things, but also I can remove duplicates. And so this remove dupe keys says if these things are duplicate, I want to remove that entire row. Be careful, right? Because sometimes I may want to sort on one or two things, but I would want to look at duplicates across all of them. Difficulty here, I need to do sorting across all of those things, remove duplicates, and then just sort on the first two. Or if I put the ones I actually want it sorted on first, it will be sorted properly, even if I put extra columns in there. Now, look at these help files, Rx sort and Rx merge. Type here tells me what type of sorting, bubble sort, that sort of thing. If you care about that, I will say I've never cared. I mean, there are reasons to care, but you know, if I'm doing work in R, that's not something I'm generally caring about. And I don't remember any questions. I've not seen any questions about type of sorting. Decreasing is important. That tells what the order it's sorting in. Rx merge, type is, you know, inner join, outer join, those sort of things. That's important. There are questions that'll talk about that. Join types. Probably everybody understands join types, so you're good there. Auto sort, merging requires the two data sets to be sorted first before it merges them. Auto sort is defaulted to true, but if you had sorted them previously, you don't need to, you could set auto sort to false because there's no reason to resort if you've already sorted them. If that makes, hopefully that makes sense. All right, one last here, and actually I'm going to skip over the work, is when you talk about using Microsoft Microsoft ML, featureize is something you can do directly on data. This is not generally the way you operate. You generally call featureize inside of a Microsoft Machine Learning modeling call, which I have an example of later. But what's the important thing is just look at the help files. There are 1 to 2 questions, maybe 3 questions about this. It may or may not end up in your exam. I don't know. So look up categorical hash, look up select features. And again, this data is shared, it's loaded, it'll be, the code is loaded up, so everybody will have access to the code also. All right, building models. The beauty of this, and I apologize if you've not used R much before, but it's just like building models in R. Estimating a linear model in open source R, you might use LM, GLM. Well, you can use RxLinMod, otherwise it's going to look just like LM. You can use RxGLM, it looks just like GLM. RxLogit, actually, though it is a GLM, was something we wrote first. It is a specific function that is a little more efficient than RxGLM for running a logistic regression specifically, but other than that, it looks just like a GLM call. You can set a family for GLM just like you would in open source GLM, but we have an extra function here, so you can use things like family equals normal, family equals binomial, but we have an extra one, which is RxTweety. There might be a question about Tweety. Tweety is a specific distribution used in loss. Sometimes it's not a lot of people use it, but it's quite efficient. So it's worth looking at the help file for RxTweety just because there might be a question about it. Knowing what it is enough. You don't need to know a lot about the internals or anything about the internals really. You can do processing on the fly. I mentioned this before. I can do transforms as I go. Much like an open source R function, I can also do things to my formula. So if I said log of y is tilde x, that would do a log as I'm doing my processing. I can do the same thing with a function here. So as I operate on the formula, I can do that. There's one extra thing here that is not in open source R, and that is the capital F. Capital F takes a numeric variable and creates a factor on the fly. And you would say, why do we have a capital F function when there is a factor function in open source R? The reason is factor in open source R, you need to know all the levels across the entire variable, right? Well, inside of a chunk, you may or may not have all the levels. So F, since it is, the assumption is it's only for numerics. The assumption is when you read into an XDF, I know because it stores the minimum and the maximum, so it just takes that span and creates that for you. All right. There is a function to do Rx stepwise variable selections. You can do stepwise variable selection in any of these linear models. Additionally, there's something called F weights and P weights. So you can do frequency weighting and probability weighting. Again, if you look at the help files for any of these, it will talk about the specifics there. There could be a question about frequency weights or probability weights. It's not a guarantee. It's that pool of things, but they could be there. Let's see. When you run linear models, and this is actually no different than open source R, missing values can affect the way things are run, right? Sometimes if I'm doing variable selection, I may have missing in a particular variable, but not in others. So that certainly can affect that. This is more of a conceptual thing, understanding that missing values can affect that rather than a code-based technical thing. There's also partitioning models, and again, just look at the help files for these. RxDtree is a decision tree or regression tree. RxDforest is a random forest, and RxBtree is gradient boosted tree. So these build all partitioning models. There is a loss function. This is actually just like rpart. If you use that, there's a loss function there that you can assign different weights of false positives there. That, again, I did not see a question when I took it about it, but it is a possibility. Now, there are a lot of parameters here, so you just look at the help files. Pruning is important, learning rate, tree depth. There's a lot of others. These are the most important because I think these are generally the ones you might see a question about. The final thing there is that the as.r part creates a open source R representation of this, so you could do plots or something like that there. Now, again, this is relatively easy. In open source R, if you say predict on a model, you can just supply it new data. RxPredict actually works the exact same way. The nice thing is that if I have a remote compute context set, RxPredict actually does run remotely and in parallel. And so this is actually very fast predictions oftentimes. There are ways, and this is just the plug to look at this help file. And I apologize, I know I say look at the help file, look at the help file. I've talked for an hour and a half. There's so much information that is required for this exam that there's just no way to get it here. So thanks for asking questions. But RxExec, if you can read about it, is a way to execute something in parallel. You can do execution of generally this is an open source R function that you would be executing in parallel. Think of it, for those who have used R, like lapply. That's sort of like a parallel lapply. Slightly different, but it is quite similar. You can pass any of the big data functions to that also. Just like open source R, you can get link return, response scores, you can get probabilities, you can get a vote for RxDeforest. When you look at the help files for that, you'll see those. There could be a question, what do I not get here? They're pretty straightforward, like, can I get a vote on GLM? Well, no, because it doesn't make any sense. That's the sort of thing you would get. Additionally, RxPredict can be used to get residuals from the regression models. You just have to specify that as instead of, say, link or response, you're going to say, I want type, residual type. Okay, so there is potentially one or two questions about when I run summary. This is like open source R. Summary on a model gives you input information out. The questions are about interpreting that. It's not how do you get anything extra. It's just what does it mean. So you'll see something about the parameters, and it'll ask you questions about that. Now there's two things here. Revo tree view, and that's actually in a package that allows you to get sort of a D3 HTML-based tree to visualize the output of a tree. There are questions that really just says, sort of look at it and understand how to get it. So look at our Revo tree view, but one question at most and potentially none. RxVar imp plot, this is actually fairly important. This is a variable importance plot, so if you use random forest or B-trees, this is important in general, not just for the exam, just because it allows you to assign importance based on how many times variables were picked. So have a look at that. So there are various metrics there to evaluate, which I'll show just a bit in code here, and then we'll be almost done. And then you can actually write custom code too. So this is just like open source R, really, right? I have sort of what I get with a summary, and then I have things I can calculate myself. It's important, and I say this example because this will probably show up. How do you compute mean absolute % error? Now, Microsoft ML had those feature hashing and things. It also has models. And honestly, these are probably the more important things in Microsoft ML, in my opinion. You have one class support vector machine for doing outlier detection, linear and logistic regressions that actually incorporate L1, L2 regularization, which is not incorporated in the Revo Scale R versions. There is a fast tree, which actually is really blazingly fast to create decision trees. You can use that actually as a recommender. There's a bit of a link for that sort of thing. And then you can build feed-forward neural networks. I would expect maybe a question or two about one of these, not all of them, right? There's not going to be tons of questions about that. There may be something about one of these questions. All right, I'm not going to run a lot of this code. I just want to show that if you were running LM, this would look exactly the same, except for it doesn't have variable selection. So I can do log of cost as a function of age and car age and type, data statement. I could replace that with LM. As long as I took that line out, it would run exactly the same if my data were in RAM. Variable selection is how you do the stepwise selection. If I leave it like this is the default. It doesn't do any selection. It's important to understand the results you will get from summary. Again, these are parameter estimates, the statistics associated with those z-scores or whatever. Depends on the type of linear regression as to what you get. Excuse me, it depends on the type of linear model, that's what you get. Here is F-weights. So again, just read about frequency versus probability weights. Understand the difference there. This is fairly common, especially in data where you have repeats of certain things. You'll have these frequency weights to say, I can compress my data and just say, well, this particular row was repeated 5 times or something. This allows me to assign a variable that would say that's how many times it's replicated. Here you can specify family. Just like you would in GLM, you do the same thing in RxGLM. Actually, this looks exactly the same as GLM would look in open source R if that were a data frame as opposed to a XDF. So I did a log transform up there. You can see I can also do other transforms on the fly. So here I'm modeling if the cost is greater than 300, and I created that variable on the fly as I'm running that. Just understand what that means, because you will see some of that in there. Now, another thing, look up Rx formula. That's one of those things. It's not a function, so you sort of need to know to look for it. But it talks a lot about how to create these formulae and what they mean. Rx step control talks all about how to do variable selection. Are you using AIC for variable selection? You can change that with a different K, so you can get Bayesian information criteria. You can replicate what SAS does with statistical tests. It's not a good idea, but you can. Partition models look exactly the same. The beauty of the modeling, I think, in R is that you can pretty much just replace the function with another function and you get a new model. If you see data formula, they all look the same. It's really nice. As.R part, as I said, will create a open source R representation. So I could do open source R plotting, say, of that tree. For predictions, again, just look at RxPredict. It is really straightforward. Again, it's just like the predict function in open source R. It's just going to be running in parallel. All right, so we have like 2 minutes. Let me jump back here. Really, to pass this test, you need to feel somewhat comfortable in using this. If you don't, there's going to be questions that you just won't be able to answer. Working with big data, I think that's just a necessity, because when you use XDF, I mean, technically everything I did today is exactly the same as if it were big data, but there's only 100 observations, right? It's just breaking it up into blocks. It's really a better thing to say, understanding that you're working on data that's not all in memory at the same time. Doesn't really have to be big. It's just the assumption is it can't be big. The machine learning models, again, you need to understand what they do. It's not really the technical interior parts, but you need to know what is a logistic regression doing? What is a linear regression for? That sort of thing. And of course, you want to take the exam and pass it. And I apologize, you're probably not ready right now to do it. Now, this is where it starts. This is not particularly interesting at the moment. This is downloadable. This is uploaded. It's there. My code is also uploaded. It is all there and available. There's number 2 if you want a picture of that, but they're all there. And I put the vignettes, sorry, I didn't even mention this one. There could, slight chance, could be a question about the Azure ML package, which is a way to take code that you've done and wrap it up and stick it somewhere. I apologize because it shouldn't be there because it's not Microsoft R Server. It is something else, but that doesn't mean that question doesn't pop up. So read any of these links, read them. You'll be ready if you read these links and feel like you know what's in there. All right, that's it. Please evaluate the session. And again, I feel like all I do is apologize because in an hour and a half, I cannot prepare you for this exam. Hour and 15, I guess. So yeah. So, all right. Well, thank you very much, and hopefully, you know, and my email is dnorton@microsoft.com. I didn't put it up there. If you have questions, I won't guarantee I'm quick to answer because I'm not. But if you have questions, I can try to answer them. So hopefully, D. Norton. Yes, sir.
Great.